All right, welcome to lesson 7.2. Today we're more solving systems of equations. We want to really key in on solving them with the values method again. So let's get started here. I'm not sure if I want to do anything on this first page. Come on, there you are. Nope, it's just a quick introduction to it. The one question they do pose here, though, is there always a solution? So we're going to kind of cover that, I believe, in this one a little bit in a moment. On this first question, we've got two people. We've got Emily and Sterling, and Sterling thinks that the two of these are equal, or will cross, if we were to graph these two, would cross when y is 19. Emily looks at this, and Emily says, I think you made a mistake on this. So think about that for a moment. Will they cross at 19? I mean, here, they both hit 19 right there. This one went from 3, 7, 11, 15, 19, 23. And this one here, the only number they have in common for their y values is 19. So is that the point where they cross? The answer on that is no. That's not where they would cross. If you'll notice, this one keeps going up by 3 each time. And yes, they have a 19 in common, but the x value is not the same. The point of intersection is when both the x and the y values are the same. So if we were to continue this one continues to go up by 4, so the next one would be 6 and 27. This one over here goes up by 3, which would be 6 and 28. So you can see that this one, they're not quite there yet, so let's even write that down. So 6, 27, and let me see if I can slide that over a little bit. Oh, come on. There we go. 6 and 27. And over here, this one would be at 6, and I think I said 28. Continuing that on, this one would be at 7, and up 4 from there would be 31. And this one over here would be 7 and 31. So as we look at this, there, maybe we can see it a little better there. While these both have a 19 in common, they'll have more numbers in common. Down here, they have a 31 in common. But while both are 31, they're also, both x's are 7. So at this point, when 7, 31, 7, 31, when both the x and the y coordinates are the same, that would be their point of intersection. All right, moving on. Question number 83, and I'm going to just kind of do something here. One of the people were at one of the fairs, the Morgan County Fair, and the temperature started at 81 degrees. But because of an approaching storm, the temperature is dropping 3 miles per hour. So let's take a look at what that might look like. I think I can just do this here. Oh, wonderful. So as I do that there, let's just jot down what this would look like. So for the Morgan County Fair, the temperature started at 81 degrees. So y equals technically it's 81 degrees, and then it dropped 3 degrees per hour, where x would be the number of hours. Although I don't like writing it that way, so I'm going to write this another way. I always like the variables coming first. So the temperature is dropping 3 degrees per hour, but it started at a positive 81 degrees. Hopefully that makes sense to you. At the same time, in the meantime, at the Larimer County Fair, they had better luck. It started at 72 degrees and was only dropping 1 degree per hour. So that would be a negative 1x, or we would call that just negative x, and started at a positive 72 degrees. So if we set this up, we know that y equals y, so we can take the one equation of the negative 3x plus 81, and we set that equal to the negative x plus 72. So we need to combine these and solve for x here. Solve for how many hours will it be until the two fairs have the exact same temperature. Well, in order to do this, we always want to move the smaller variable. Normally, I know you would take a number like the negative x and move that, but the smaller variable, if you think about this on a number line, is a negative 3x. So we're going to add 3x to both sides of the equal sign. After I get done doing that, this side of the equation is left with an 81. The other side of the equation is a 2x plus 72. Next step, subtract the 72 from both sides. So we'll subtract 72 from both sides. 72 is on the right side, you'll see it'll cancel. On the left side, we've got 9 equals 2x. Okay, well, we don't want 2x, we just want to know x, so we've got to divide both sides by 2. So divide by 2, divide by 2, and we're left with, it will take 4.5 hours until these two are both at the same temperature. Hopefully that makes sense. So we take this equation here, and we set that equal to this equation here. And you can see I did that right here. And then from there it's solving for x. We first combine our x's to get those on one side of the equation by moving the smaller one and doing the inverse of the smaller one. Once I've got the x's on one side, in this case I've got the x's on the right side, I want to move my numbers to the left side. So the opposite of add 72 is subtract 72. We got 9 equals 2x. X is being multiplied by 2. The opposite or the inverse of that is to divide by 2. The 2's over on the right side cancel, leaving me with an x, and the 9 divided by 2 on the left side leaves me with 4.5. Hopefully that makes good sense to you. Moving on. All right, on this next one, we need to answer a few questions. This is all about saving money, or in one person's case here, spending money. Who is saving money the fastest? Well, saving money the fastest means that their line is going up the steepest. And if you would agree with me, that would be our friend Laura here, who's going up the fastest. There's one other person who's going up, which is Paul, but Paul just doesn't save quite as fast as Laura does. Who is not spending or saving? How can you tell? Well, if they're not spending money, they're not going up. I'm sorry, if they're not saving money, they're not going up. If they're not spending money, they're not going down. So who's not going either up or down? You might be saying Nick. His line's going flat. It's not going up, he's not saving money. It's not going down, he's not spending money. So Nick is just staying flat. When did Paul and Melanie have the same amount of money? Well, here's Paul's line. Here's Melanie's line. And Paul and Melanie met right here, which would have been 3 weeks, and they both had at that time $500. Will anyone run out of money? Yeah. If you're a spender, like our friend Melanie here, she's going to run out of money after how many weeks? 8 weeks. Hopefully that all makes sense to you. Let's see what else we got today. Oh, we got some fun ones here. You have your choice. When you come into class tomorrow, I want you to do one of 3 problems. Setting these up. You can do this one. Jenny has $320 in savings and is saving an additional $12 per month. Gavin has $544 in savings, but spends $20 per month. So one of these is going up, one is going down. I suggest you set it up using the equal values method. Do not graph them. Please set them up using the equal values method. If you don't want to do that one, you can do this one. It's kind of a fun one here. Sarah wants to lease a new Lamborghini. Here's her new Lamborghini she wants. She can lease it at Awesome Imports for $13,000 down and pay $3,000 per month for 3 years. Or she could also lease cars from the rich and lease it from Cars for the Rich and Famous for $25,000 down and only $26.25 per month for 3 years. If she plans to keep the car for all 3 years, I want you to determine who's got the better deal and by how much is it a better deal. And also, after how many months do both companies charge the same? So that might be within the 3 years, that may not be within the 3 years, but I want you to determine how many months until they charge the same. So you can choose to do the Lamborghini problem. Or, if you don't choose that one, by the way, any problem you want to choose, you should just pause the video at that point. Casper has 4 goats, 4 of these guys, and 1 lamb, which eat 21 pounds of grass per day. Count Chocula has 4 goats. You know what this is? I'm just realizing this is too hard of a problem for you. Please don't do this problem. So, if you want to do the Lamborghini problem, pause the video right there. If you want to do the other problem, pause the video right there. We'll see you in class with that one done. Thanks. Bye.